Welcome one and all to week, whatever this is, 6, 7-ish. We are going to continue with SQL this week. We are going to start delving into the select statement. Last week we covered the basics of DML, which is select star from whatever, the simplest statement of them all. I also covered how to insert, update, and delete data. And I also taught you guys how to create tables and change them and how to get rid of them. That's the basic DDL, and I taught you guys, the basic DML. Now we're going to get into the more complicated side of the DML. The select statement. As I said, theoretically you could spend an entire term teaching the select statement. It's a continuously learning experience for everyone that uses this language. In the last 3 years, I've had one student teach me something I had no idea even existed. It was the coolest thing ever, and I actually had a reason to apply it 3 weeks later at work. So it was just good timing. And about 2 weeks ago, I had to learn how to do something else I'd never done before. So to give you an idea, the select side of DML is quite large and extensive, and there's so much functionality that unless you actually need to use a certain piece of functionality, you don't even know it exists. But today, I'm going to stick to the simpler SQL statements because we're going to be spending the next couple of weeks on it, specifically on the selects. And there we go. Okay, so what am I going to cover this week? I'm going to review the basic select statement. I'm going to talk about selecting distinct records. I'll talk about ordering your results. I'll talk about aggregate functions and aliases. Time permitting, I'll talk about some useful functions. That's no guarantee at the end. Then we're going to stick to what's called simple, the simple side of the SQL language. Okay, the select statement, to have a little more information about it, it's used to retrieve records from the database. You're selecting records out of the database. That's why they used it select. You're picking records out of the database. It's very, very flexible. The amount of stuff you can do with this is crazy. You can use it to return records. You can also do it to do calculus. It actually can behave as a calculator if you wanted to. Why would you do that? I don't know, but you could. Pretty much every major math function you need exists in the database. You want to calculate a cosine of something? Away you go. It can do it. You want to figure out the standard deviation? It'll do that too. It'll do the maths. It is made up of, and I made this sentence kind of funny looking, 2, 3, 4, 5. No, actually there's actually 6 pieces to this select statement. Today we're going to do the first 3 or so. And the select statement builds up as you go, so it gets more and more complex as you learn about it. But we're going to learn the simple part of it first. So the basic 3 pieces of a select statement are as follows. There's the field list, the table list, and the conditionals. Now, you guys have started to learn Java, and with Java, it's a standard programming language where, except for needing a function main and some basic instructions, that's all you need to basically write a program. But it's pretty fairly free form. As long as you got function main, you can do whatever you want inside of it in whatever order you want within reason. SQL is not like that. It needs very specific pieces. At the bare minimum, it needs a field list and a table list. The conditional list is if you want to filter your results a bit. The field list, there's 2 choices. There's the option which is the asterisks, which means grab all available columns. So select star, which you can see right over here, right below. Select star means grab every column that you can see. Not you personally can see, that the database server can see. So if you go select star from users, it'll return every column in the users table. Or you can return a set list of columns, and you separate them using commas. For example, select ID, comma, name. And this is important. I had a former database prof that used to get really angry at students that use select star, because select star is lazy. It's great when you're exploring the database and you don't know what's inside of it, but after you've figured out the structure, you should stop using the asterisks. Why? Normally, on large enterprise, database servers aren't running on the same machine as the application or the application server. They're separate machines. That means there's network traffic between the two. And if you do a select star and your record is fairly large, so each record could be, say, 1K. So a K doesn't sound like much. You guys know if it's a K. What the heck is that? It's not even, an icon's bigger than a K. Yes, it is. However, let's say you retrieve 1 million rows at 1K a row. How much data is that? It's an awful lot of data. You're talking about hundreds of megabytes, if not a terabyte. And it returns that. But the problem is one server is building up this list of information, this megabytes of information in memory, finishes building the list, squirts it across the network to another server, which then receives it and has to handle this huge amounts of data. On the other hand, if all you ever needed was the person's ID and name, each record might be 20 bytes, 30 bytes. So 20 bytes, maybe even 100 bytes times a million is significantly less. That means instead of moving an elephant through a tiny pipe, you're just moving, a mouse through the tiny little pipe. You're just trying to shove more through that hole. Just like, anybody here have a shitty internet connection at home? You go to download something and a 20 meg file will take 5 minutes to download, as opposed to, where I work, where I can download a DVD in 36 seconds. The difference in size of pipe, right? The pipe's only so big, only so much can move through it. And the select star basically tries to shove a lot of stuff through a tiny hole. And out it goes. And I can do actually a quick practical demonstration to show you guys the speed difference. Now, this database server obviously is running on my machine. And it's just like yours is. So if I did this, and I hit the run button. And if you can see the bottom right corner, 3.4 seconds to run. Okay, great. But if I wanted to just say I want to just have the ID of the orders instead, 500 milliseconds. And that's running on my local machine where it doesn't need to even go reach across the network from one machine to another machine. That's why you don't use select star unless you have to. I'll use select star a lot in class just to show you guys what the structure of the tables look like. But when you're actually developing later on, you don't want to do star. It's just a bad habit. So once again, common delimited field list works like magic. So the table list is the next thing. That's the from clause of the statement. And there's three kinds of table lists. There's single tables, which is what I'm doing this week. So I'm selecting data from only one place. Then there's joins, which I'll be covering 2 lectures from now, maybe. 1 or 2, got to remember. And then there's derived tables, which will be covered at the same time because they're kind of related to each other. So the clause, it would be from, in this case, from test. And the example I had up on the screen is from orders. Basically from whatever table. So, actually if I go, this is the same. As you can see, I put a carriage return in it. I'm just putting it up to break down what it is. And as you can see, I actually added one more column and I had doubled the return time on it. Just, showing. But basically the first line is our select. What are we selecting? The second line is where are we grabbing it from? And then it leads us to the third line, the conditionals. Now, you guys have just learned about conditionals in Java class, apparently. An if statement. Yes, you've learned about if. That means you now know what a Boolean test is, right? It returns true or false. Okay. Hot damn. Last time I taught this, Howard hadn't gotten to it. So I was explaining Boolean logic to people. The where clause is a series of Boolean expressions. They either evaluate to true or false. You have all kinds of operators you can work with, and you can have multiple clauses. And you have brackets. Just like an if statement in Java where you can go, if I greater than 5, do this. And if you want to do more than one conditional, you can do if I greater than 5 and j less than 3, right? Double ampersand. But you have to, sometimes you put things in brackets if you want to group them. Just like in math, when you group up an equation in multiple brackets, same deal. You can actually, because there's a certain order of operation when certain things happen, just like in math. Now, we have the standard comparison operators. The normal set, which you guys are used to seeing, less than or equal, greater than or equal. There's also greater than, which I seem to be missing in my slide. Not equal, which is now accepted. The not equal from the C-like languages is finally accepted in most database servers. Postgres just got it one version ago. Up till then, we used to have to use the diamond operator. And it's still perfectly acceptable. And the equality check is a single equal sign. This one trips up C-like developers. You're used to double equal signs, equal, to check if I equals 6. In SQL, it's just a single equal. So that's the one that's going to throw some of you guys for. You'll get errors. You go, I know what this means. Do you have more than one equal sign next to each other? That's probably your mistake. But like I said, the not equal operator used to be the diamond operator. We called it the diamond operator because it's impossible for something to be less than and greater than at the same time. Is I less than 10 and greater than 10 at the same time? Can it be? Is it possible? No, it can't be. Therefore, that's why. Is it less than this and greater than this at the same time? No, therefore it's not equal to this. So I'm going to tell it retrieve the order. It has an ID of whatever that is.